Saxon Algebra 1, Lesson 51. This is part 2. We're picking up in the middle of example 51.1. We're graphing the line, and we were in the middle of making the table when my lesson got cut off. So here I am, back again. All right, so we get to choose whatever values we want for x. That can be profoundly confusing to some students because they don't realize we really do get to choose whatever we want. We just choose simple values. We started with 0, we calculated the -1. Let's choose another value because we want 3 points in all. Three points will determine a line for us. We found that one of the points on our line will be 0, -1. Let's try 1 for our x and see what that gets. So again, we take this value, we plug it in here. 2 times 1 minus 1. 2 times 1 is 2, so I'm just going to cross that out and write it 2. 2 minus 1 is 1. Okay, so there's another point that will be on our line. And now we can choose anything we want. I'm going to choose a negative number just to be fun. We'll choose an x value that's on the negative side, right? And let's just see what we get. I'm going to choose -2. I want a negative number. I would never choose a fraction or a decimal. Never. That's just making it too hard. And again, I like to keep my numbers small so that I'm staying close. I don't have to make my graph really big, right? I'm staying close to the origin, the center of the graph. We could choose 465.3 and plug it in here. We could do it, but it would just be a much more complicated process and we'd have to make our graph much bigger. Okay, so now we're doing 2, so I plug -2 into this. 2 times -2 is -4. We use all our order of operations rules, that kind of stuff all the time. -4 minus 1 is -5. Okay, so let's just go ahead. Again, like I said, you don't have to write this over here, but in the beginning, it's really useful for trying to keep straight what we're doing. So our second point will be 1, 1. And our third point will be -2, -5. Okay, I'm going to flip the page and I'm going to graph these 3 points on a fresh Cartesian coordinate system, and we're going to see if they do indeed make a line. Oh, I wanted to say a few things about this table before we go on. No, I don't. I'll say it later. Changed my mind. I want to give you the full glory of seeing how this turns into a line in just a minute. Okay, so my points were, I'm copying them from my notes on the last page. 0, -1, 1, 1. If you didn't flip the page, you wouldn't have to write these again because you have them in front of you. Okay, so now all we do is graph these. So I draw myself a basic graph. If I had a Post-it note, graph paper, I'd slap one on this page. What I'm doing is I'm making my numbers on the x-axis about the same distance as the blue lines on my page. I'm never exactly precise, but this gives me, see, these are a little too far apart, aren't they? But it's close enough, we get the idea. I'm trying to make them that far apart, I failed. All right, 0 minus 1. We go to 0 on the x-axis and -1. 1, 1. +1, +1, and -2, -5. 1, 2, 3, 4, 5. Right about there. Now, you can use a straight edge or a ruler if you've got one. Honestly, this is what I usually do. I just grab something that's straight and I look to see if that's going to line up. And look, even with my lack of graph paper and wonky ridge, that looks pretty good, doesn't it? Those 3 points made a straight line. If I made a mistake in one of my calculations, the 3 points would not create a solid line, and I would realize, uh-oh, something, I don't know which one, but one of these points is wrong. And I would go back to my table here, and I would check my calculations and see if maybe I made just a little arithmetic mistake in calculating one of them. The 3 points, no matter what you choose for your x value, they should line up and make a line that is called y equals 2x minus 1. That's the name of this line, is that. And every single pair of points every single point on this line will give us two numbers that if we plug in the x, we'll get the y back. Okay, so all of the points on this line will make this come true. And that is the beauty of what this is. This is called a linear equation. It's also sometimes called a linear function. Function is a word that we're going to toss around more and more as we go further in math. Don't let it scare you. All it means is that for every variable you put in, you'll get a certain number out, and it'll always be the same, right? Every time we put 0 into this equation, we'll always get -1. It won't change. That makes it a function, which is just a fancy name for an equation. All right, so I want you to get used to that, throwing that word around so that it doesn't frighten you. Okay, let's make the next one, and when we get to the table in this one, I'll tell you a little bit more about why I do it the way I do it. So here we go, example 51.2, and this time, let's see, there are 3 in all. No, we're gonna get a little bit more. Example 51.2. And here's our new equation. John asks us to graph y equals 1/2 x plus 2. Okay, we can see it's just like last one. The numbers are a little different. We have a fraction. We won't let that scare us. We see that it's y equals and then something times x plus, or it could be minus, another number. That's the typical equation of a line. We're going to see it over and over again. So the first thing we do is we set ourselves up with a table. We remember that we choose our x's and we calculate our y's. We use this part for the calculation. Whatever we choose for x, we're going to multiply it by 1/2 and then add 2. Now, I don't know about you, but I would really like that fraction to go away. I don't want that fraction in my life, right? And I certainly don't want to be trying to graph fractions with halves in them, right? Ew. So what we want to do is when we're choosing our x values, we want to be clever about it, right? So what I want to do is I want to choose numbers that when I multiply my number by 1/2, the denominator will go away. Let's talk about what might be good for that. 0 is a charmer because look, 0 is always going to wipe out whatever we're multiplying by here, right? Because 1/2 times 0 goes to 0. 0 plus 2 is 2. And so there's our first point. Aha, I don't have fractions in my answer. That's my glory. Okay, let's try this. If I pick 2 for x, then the 2's will cancel, right? 1/2 times 2 will be equal to 1. Look, I'll write it as 2 over 1, right? And then we'll add 2 to it. So this is a good number because it cancels against that denominator and the whole thing goes down to just 1, right? 1 plus 2 is 3. So there's another lovely pair of points that do not have fractions in them. Now, since this worked so well, my brain says, hey, let's try -2. And that will cancel it out. Oops, 1/2 times -2 over 1 plus 2. So once again, the 2's will cancel. Instead of being +1, though, this will become -1. -1 plus 2 is +1. And so our next pair of points is 2, 1. Yay. What we find is that if we choose any even number for x, like if we chose 4 or 6 or 8, that will cancel against the denominator, right? Any number divisible by 2, we will be able to cancel it against the denominator and we'll get rid of our denominator. So I would never want to choose an even number, like 1 makes it 1/2 plus 2. Ew, I don't want that because that's 1.5. And now I have to graph a half. I don't want to do that. So look at the denominator and think about what numbers you can choose that will cancel against that and make the denominators go away. Now, here's what John does. John makes his tables in a different way, and I just want to show you what he does so that when you see them in the book, it'll make sense. John makes his sideways, right? I make mine go down. He makes his go sideways. And he does not have this middle column of a workspace where you can actually do the calculation. So what he would do is he would say, okay, let's choose 0 for x. And then he would go over here and he would do a side calculation where he did this. Over here to the side, 1/2 times 0 plus 2 equals 2. And then he would write the 2 down there for the y. And then he would do the same thing. He would say, okay, let's choose 2 for x. And he would do the calculation. He'd say 1/2 times 2 plus 2. Oh, that equals 3. And he would put it here. And then he would do the same thing for -2. He would do the side calculation. And he would get that, right? So his points are exactly the same, but there is no room to do the work. And then this is the part that really kills me. Here it's very easy to see, oh look, there's my point, 0 and 2. It looks organized in front of my eyes as I would expect it to be. These are above and below. So here it's a lot harder to just let your eyes grab the points because they're not written next to each other. They're written above and below each other. I don't like this. This is John's way. So you will see in the book, John's table is looking like this. Here he's chosen all of his x values. You also don't have to choose 4 x values. That's too many. 3 is all you need. But he does his sideways. Don't do it. It's not good. The other thing that may frustrate you with these problems is that because we can choose any values we want for the x answer, when you go to, I'll just show you a random problem. These are from the practice of this lesson. So here's John's table. He drew it sideways. That's a little weird. We do it the other way. He doesn't show his work, but the other thing is that he may choose different numbers than you choose doing your homework, right? I choose them when we're doing the examples in the book, but when you're doing your homework, you get to choose the x values, whatever you want. And you may choose numbers different than what John chooses. That sometimes frustrates and confuses students, and what I'm here to tell you is you don't have to match his numbers. You can do your own numbers. As long as you're sure you calculated correctly, your numbers should work too. So when you come here to the practice problems, or to the solutions manual rather, you may not see the x values you chose. If you're really frustrated and annoyed, try using his values and then calculate your own. Okay, so that's a little tip I would give you as how to use the solutions manual if you're not getting it right yourself. But that's a last ditch solution. You should be able to say, no, my values should work. It's okay if they don't match John's. That's what the line should look like. Which of my points are lining up here and which ones are not. So don't let these tables frustrate you or confuse you. We're not going to be using them that long, so don't worry. They're going to go away fairly soon. All right? Be sure that when you're using your solutions manual, you're doing it correctly, right? There's a difference between looking at this to jumpstart your brain and just copying the answer. The biggest thing I can tell you is that when you look at your solutions manual, you shouldn't be writing anything down that you see, right? You're looking at this, you're figuring out how John did it, but you're not copying any of this down. Okay? You're just looking at it. If you're absolutely desperate, you could copy a couple of his x values, but you calculate your own y's. You don't copy his down. All right? So if you're copying things from the solutions manual, that is a danger sign. You should only be reading it as a tool book, a toolkit. It's like a recipe, right? You're just looking at the steps, and then you go, okay, now I can do my own work, and I don't need to look at that. Okay. So we're not going to do it John's way. We're going to keep using our table. And I'm going to draw a little quickie graph right here so we can graph it. All right, I'll put a few marks on here. I'll try to make them look better this time. I do not usually make these. I'm just doing them because we're starting. I put in 3 in each direction. If I need more, I'll add more. But you don't have to add. You don't have to make a whole big detailed graph with lots of numbers on it. Keep it simple. 0, 2, 2, 3, and -2, 1. That looks pretty good, doesn't it? It looks like we lined up pretty darn well, so I will use my fancy straight edge here and connect the dots. That turned out pretty well. And so this time I'm just going to draw an arrow. That is the name of that line, right? Y equals 1/2 x plus 2. Yay. Okay, let's keep going. This one is going to be so easy, it's going to look hard. We're supposed to graph the equation y equals minus x. What? There's no calculation. How do we do this? Don't worry, it's easy. We draw the table our way. The x goes there, the y goes here. Here's the workspace. We choose values for x that will make our life easier. There's no fractions or anything we have to deal with here, so let's just choose 0 because always. Okay, then we just plug it in. Minus 0 is also 0. Okay, let's choose 1. And let's choose minus 2. I'm just mixing it up. I choose one positive and one negative. I keep the numbers small. I use 0 as 1. And I thought with this minus sign, this might be interesting. Minus minus 2, that means this will be positive 2. All right. I have no idea if these are right. I'm not going to rewrite these as points this time. I'm just going to work directly from here. So here's my Cartesian. And I'll just do 3 in each direction. As I glance at my chart, I can see my numbers are all between 0 and 2, right? Even if they're positive or negative. So this will be big enough. And now instead of having rewritten the pairs, I'm just going to look at them. My first point is 0, 0. My second point is 1, negative 1. So 1, negative 1. And my third point is negative 2 and positive 2. Negative 2 and positive 2. Oh, those look nice and straight, don't they? Looks like things went well for us. And my line didn't go through them as perfectly as I'd hoped, but that's pretty good. That's good enough for us. And then we can say, again, the name of this line is y equals minus x. And if I look at John's line in the book, his table doesn't look like mine. Look, I'll show you. His table does not look like mine because he chose different values. He chose 0, but then he chose 3 and negative 3. So when he filled it in, he had different values. He does have the 0, 0. That's the same as me. So that encourages me. But I chose different x's, so of course I have different y's. That doesn't surprise me or freak me out. I just want to see what the picture looks like when he graphs his 3 points. And look, it looks exactly like mine because mine goes through 0 and it splits the quadrants right down the middle, right? It goes right down the middle. And look at mine. It's a hair off. It should be over a little bit, but it does the same thing, right? It goes through 0, it's tipped down, and it goes right down the middle of the 2 quadrants. Yay. So that's good enough. If the picture looks the same and any values for x that you chose that are the same as John's values, those should match. But if he chose different numbers, it's fine. Don't worry about it. 51.4. Now we're going to go into a slightly different, a specialty niche. We're going to talk about horizontal and vertical lines. Lines that are perfectly straight, either this way or this way. Their equations look a little bit different. And we're going to take a look at those. We don't see them very often, so don't worry about them too much. But we'll play around with them. X equals minus 2. That is the equation we're given to graph. And we go, that doesn't look right. That doesn't look right. That doesn't look right. Because what it tells us is that for our x, we always choose negative 2. How do we make a table where with that, there's nothing to calculate? That's right. So what we do is we go here. Let's put minus 2. There's the x. This is the x-axis, right? And this is the y. So this is x equals minus 2. And what it means is that no matter what y value we choose, x will always be equal to negative 2. So what this becomes is a line that looks like this. Pretend it's perfectly straight. It's a vertical line. And that tells us that when the line just has an x value and no y, it's going to be vertical. It's going to go up and down like this. Because what we're saying in this is that we're not even going to talk about the y. No matter what y is, x will always be minus 2. And that's what our graph shows us, is that x is always minus 2. The y changes, right? There's y is 0, y is 1, y is 2, y is 3, but x is always minus 2. And so that gives us the picture of a vertical line. I'm going to do example 51.5 down here so that you can compare them. In this one, we have y equals 4. Okay, this one also looks weird. It's just got one letter, but it's going to yield a slightly different picture. In this picture, it's the same thing. We don't have to make a table. I'll put these on here again because it's helpful to keep it straight. You can put these on the x and y. If that helps you, go ahead and do that. Sometimes when students are starting to graph, it's very helpful to write the x and y just to remind you which one's which. But as you get more experienced, you can drop that off. Y equals 4. Okay, the same idea is working here where we go to y equals 4, which is all the way up here. And what we're saying is that no matter what the x is, y will always be equal to 4. All right, so this style of equation will give us a horizontal line. All right, so when it's x equals, that's vertical. When it's y equals, it's horizontal, right? This is horizontal, this is vertical. I'm just going to write this here by it so we know the name of it. You don't have to memorize that, although if it sticks in your brain, that's good. The main thing I want you to remember is that when you see the equation of a line and it's just one letter equals a number, you know it's going to be one of these weird ones, and you can just logic it out. Right? X equals minus 2, that means x is always equal to minus 2. So you just draw a line that shows minus 2 no matter what the y is. Here we say y equals 4, so we go to y, 4 on the y-axis, and we draw the line this way. Okay? These are weird. They don't come up often. If you can remember that they're both freak children and then logic it out, that is the most that I ask for. All right. And then we have one more problem. (51.6). And this time what we're asked to do is to put two equations. We're asked to graph two equations on the two lines rather, on the same rectangular coordinate system. Okay, so one of them is y equals 2x. Okay, that looks like more like what we were doing in the beginning. There's no plus or minus, but that looks a little bit more like what we did before because it has two letters. And then we have y equals 2. And that looks like one of the weirdos, doesn't it? So let's go over here. This one we're gonna say, we're not gonna do a table for this one. This is one where we'll just logic it out. Here we'll do a table. This looks like a normal table type calculation. So we look at this and we think, what values can we choose for x? That will be easy. There's no fraction to worry about. So that's good. Let's start with 0. That will be 2 times 0, and our y value will be 0. Okay, yay, that's easy. Let's choose 1. That will be 2 times 1, that will be 2. And then let's choose a negative number. Let's choose -1. And I'm just going randomly. I like to choose positive and negative just because it gives you a little bit more variety, honestly. It's just something interesting. But if you wanted to choose all positives, you can. All right, so there are our 3 values that I chose. We don't need to do a table for this one because we know it's one of the weirdos because it only has one letter. There's no x in that one. So let's draw. gosh. Got a little crooked, didn't it? And like always, I'm just going to sprinkle a few values on here. And we'll graph this line first. We'll do these points. 0, 0 is my first point. It's right smack dab in the middle. 1, 2, 1, 2. And then minus 1, minus 2. This is a bleed through from the other side of the page. That is not a point on our line. So I put a little X through that. Don't want to confuse you. Okay, so there's our 3 points. Here is another straight edge that works really well, right? This is my lesson checklist. I'm using it folded to the old side, right? And look, those line up pretty darn well. So this is y equals 2x. This is very important to me, that you label your lines with the equation. I want you to connect the fact that this equation is this line. This line is a picture of all the different values of x and y that will make this come true. Now we'll graph this one. We don't need a table for this. Y is always equal to 2. So we go to y equals 2, which is right here, and we draw a line. I'll use my page again. Okay, so there's y equals 2x, and this is y equals 2. And what we see is that these two lines intersect. That is going to be useful later. I'm not going to talk too much about that now, but the fact that these two lines connect is a very interesting part of their personalities, let's just say. And later we will talk more about what that means, all right? But for this lesson, we learned how to graph lines using the table method. Later, we're going to talk about an easier, more efficient way to do it. Guess what? I'm done. Thank you. Goodbye.